And until last year I ran part of the first year design classes for the School of Engineering. I'm still involved in the final year mechanical engineering design. And I like to do stuff which is multidisciplinary, interdisciplinary, cross-faculty, cross-disciplinary, whatever you'd like to call it. It's stuff that goes a little bit beyond the borders of engineers. And I mean, your organization is called Engineers Without Borders. As engineers, we have borders around us. We see the world from an engineering perspective. And when Joel and Kay asked me whether I could give a presentation, I thought, hey, maybe you want to have a bit more than just an engineer talking about, you know, an engineer going beyond borders. Maybe you want to get a viewpoint from the other direction as well, and that's why I've brought my colleague Professor David Walker, who's working with me on a great project that we are both are doing, which is called EWBNZ. Yes, up there the logo, which is about innovative new product development for New Zealand businesses. Not exactly what you're doing in Engineers Without Borders, but also crossing boundaries. And David is not an engineer. I have to warn you, David is an architect, and he's been involved in management school, and but he's sympathetic to engineers. He even believes that engineers are also creative. He's a creative person, you know, from outside. He's from the creative design area. And he's put this presentation together about creativity, design, about social responsibility, about engineers going beyond their borders and doing things with other disciplines and other domains, and really about getting an understanding what engineering is all about in the modern world, the roles of engineers and stuff like that. And we are trying to do it together, although David will probably do most of the talking, and maybe I just pass on to you and you get started with your presentation.
Because I'm not an engineer, it means I'm not very rational or systematic. So here's a load of stuff for you to think about. Visually led. If I just press the button, does that make each slide go?
The arrow key is the safest.
I like this quote from Albert Einstein: technological progress is like an axe in the hands of a pathological criminal. In other words, lots of technology goes wrong, and let's hope you're not the mad axeman. There is the wonderful Jack Nicholson in The Shining, so good at portraying the madman. Don't be a mad axeman. So what I'm going to cover is, what is the role of professional engineers? How do you operate within something we might call the development funnel? How do you actually have power within an organization, wherever it is, whatever it is? How do you have an understanding of business? How do you understand the end users of whatever products and pieces of technology you're putting together? And the big question, which I'm sure is on your minds, and which is the reason that you define yourself as Engineering Without Borders, is how do you deal with the big issues of social responsibility? And I'm absolutely with you on that, okay? It's not just I feel sympathetic to engineers. I think you have to use your engineering skills to solve problems that are really pressing, and they are global, and they affect all of us. So you know really how you do this. You think systematically, because engineers are good at that. You think creatively, and I think engineers have a tradition of being creative in detail that we'll look at in a minute. But you also think of solving problems in a sense which is unselfish. So those are the themes. The value of engineering. Think of the world without engineering. This is rather a nice drawing where you haven't got your PlayStation or your telly or any of the normal artifacts you surround yourself with. The world without engineering would be quite a peculiar sort of reduced place, because you are the guys that make things work and carry things through to the point of execution, and sometimes with very sure-footed kind of brilliance. And I would encourage you to be proud of that and to work within that tradition. So the kind of things that engineers are good at are being inventive, inventing things almost from scratch, or certainly with new principles, and then they're good at the other end, which is just making things work, you know. Who puts in all the grunt and the effort to actually get the details right to make sure that, you know, a good idea doesn't fall to pieces? So whenever you're driving on the motorway looking at a motor car, you think this is a really extraordinary piece of technology that's had, you know, 100 years of development, and it's just amazing that it works at all to me. Not that I think the system of transport that is embodied in the motor car is that good. So you're good at this kind of stuff. And when you begin a process of invention, you don't always know whether it's a good idea or not. Some ideas turn out to be cul-de-sacs or dead ends. Here's a couple of inventors. One has got this rather strange motorized unicycle. Does everybody know who this is? This is John Britton, the guy that pushed forward the art of making motorcycles with this artifact here. He is the archetypal Kiwi inventor, doing it with a small team in a shed on a shoestring and producing world-beating products. What's the difference between an invention and a design? Well, this might reiterate some of the foundation stuff that you've done in your courses. An invention looks like a load of junk, essentially. This is a flying bedstead, which is a vertical takeoff aircraft, and then it's converted. Sometime later, maybe there's a 10 or 15-year gap between these two artifacts. An invention actually doesn't look like anything much. It just embodies the principle. To make it fully formed, it has other kinds of design as well as engineering involved, okay? So it's important to remember that. So almost every piece of technology, when it begins, looks more like an experiment in a lab than a real artifact that you would buy commercially, okay? Gradually it gets cloaked in other things. This is maybe 10 years later from the last slide, and the designer has done this really nice Art Deco enclosure in Bakelite, which was a new material of the day. Okay? Like, that's an early form of plastic. And it's pretending to be wood, which is rather strange. But only 10 years between those two things. If you look at any of the major artifacts of the 20th century, you'll find that the engineering component on it is quite strong. This is Henry Ford on his quadricycle, his first car before the Model T. Ford was an engineer. When he put together the Model T, there was about 3 people involved. It's a bit. The Model T is a few years later, which is an extraordinary kind of achievement, not just in terms of the artifact itself, but the system of manufacture, which was the origins of mass production. And what you've got to imagine is that 3 guys who have got engineering skills, they're quite young, I think in their 30s, and they're in this big shed in Baton Rouge in Chicago, and they're walking up and down the shed, and they're laying out a rope, and they're putting knots in the rope, and saying, oh yeah, the engine could sit there, oh yeah, the suspension could sit, oh yeah, we could do this. So they actually, in their heads, were modelling the whole process of manufacturing in a way that no one had ever done before. And that, to me, is creative. And it's a creativity about a manufacturing system that led to a massive, massive explosion of mass production. So, by 1924, the Model T car, they'd sold 10 million. And they were producing them at the rate of about one every couple of minutes would be coming off the production line. You think of a modern production line, and it's probably approaching that kind of thing, but they were doing this by about 1912. Okay. When you're working in one technology, you always have like a carryover from an earlier technology. They didn't quite know how to do the wheel of a car.